Hello, this video will explain how Team Estimate 2533 went about randomizing different question formatings or question formats and kind of sticking to our ultimate or our main design goal of having every question being randomizable and autogradable to allow for each student to get a limited practice with the question by being able to randomize different parameters of that question, and then also with auto grading getting instant feedback upon submitting an answer. And this video will cover or kind of go over and complement or go alongside the anti-randomization documentation that's been made by us. So as mentioned before, this video will be going over the PrairieLearn anti-randomization documentation, and more specifically, it's going to go over the whole documentation. So it's going to go through every section, such as why we want to implement randomization, or why we did implement randomization into PrairieLearn, how we went about implementing it, what the final product looks like for some problems, and then further going into how we randomized different types of questions. And so kind of the first example or first explanation of how we've gone about randomizing questions is the example over homework 1 question 5, where when starting this project, this question used to be in the format of, it had the same question, it had the same kind of multiple choice or drop-down selection approach for, choosing which component you thought, or was one of the components that made up the inside of a microcontroller chip. But then we used to have, or there used to then be for the description of this component, the student would write like a short answer response, like within a text box, and that would happen for all of these components. And that design approach or that formatting doesn't align with our design approach of wanting to have every question being randomizable and auto-gradable, because it's very hard to auto-grade a student's short answer response, because a short answer response can be anything that the student thinks of, and with having a short answer response, then that would make the question become or at least those portions of the questions would then have to be manually graded, which once again is breaking our kind of key question design here. And so to incorporate randomization and auto grading into into this question in particular, we changed the formatting of how a student would answer the description of each component to being similar to how a student chooses a component for the microcontroller, which is having kind of providing them with 6 different kind of description answers, and then they have to choose which one they think is correct. And so the randomization comes in with how these answers are created. So there's one correct answer that we kind of hard code, and then the rest of the answers, or the 5 false answers, are false, and we randomize then those false answers. So if a student was to randomize this, I guess they wouldn't all be getting the same options here. And so the way that we go about randomizing, 5 out of the 6 options here that are not going to be correct is, that all takes part in servo.py. That's where you're going to be doing pretty much all of your randomization for, all homework questions. And so for the first question, or first part of the question, where you're picking the component 1, or the first component, we have this true story string where we've hard-coded the correct answer. And then we have this story string, which this is a template that will form the 5 false options, or 5 false answers, where the noun, the role, and the verb, these spots are going to be each of these spots here are going to be randomly picked from kind of the possible list of nouns, roles, and verbs that we've come up with. So in this for loop here, it's going to iterate through it 5 times. Every time it iterates through, it's picking, a different noun, a different role, and a different verb at random from these strings arrays, or picking a string randomly from these arrays, and replacing that placeholder within the story string. And then once that's been created, it puts it into this Q1 answers array. Like I said, it's doing it 5 times. So at the end of this for loop iteration, or at the end of the 5th iteration of this for loop, there should be 5 different option strings within this Q1 answers array. And then for the true answer, or the correct answer that we've hard coded, we then set that up as, or we set those parameters. So we have like a parameter here called A1, and so that actually holds the string value or string representation of that answer, and then the A1 answer that contains the Boolean value to say if it's correct or not. So in this case, A1.correct should return true. And then these parameters are used in this question here to designate, hey, this answer is correct, so this should return true. And then using the A1 parameter to actually show the string of that option so that it shows up within the dropdown and can be selected. And then with using PL multiple choice, or using the PL multiple choice element here, it will randomize the ordering of these options or of these answers. So, it might look like, hey, the correct answer that you're setting is always going to be the first answer, but in fact, the ordering is going to be randomized every time. So, like here, the correct answer is C here. But if I go ahead and create a new variant of the question, the correct answer then becomes A here. So then, yeah, that ordering of all the different options gets randomized. And then this kind of randomization that we do for the first question for creating these five false or 5 different options, we use the same format for then the rest of the questions as well. Or like, for question 2, for coming up with all the different options for the descriptions for component 2. Once again, we're using the same list of nouns, verbs, and roles. And once again, hard coding the correct answer and then coming up with a template for the incorrect answers or the different false options, and then using a for loop and iterating through that 5 times to fill in this story variable and randomly picking a noun, verb, and a role, and putting that, creating 5 different strings, 5 different false options, putting that into Q2 answers, and then setting those, or setting parameters for each of them, those false options, so that they, then show up within the drop-down menu of the question and, are declared false as shown here. And yeah, so that's how we approached randomization for this one type of question, and we use a somewhat similar approach for a lot of other questions as well. All right, so continuing with question randomization, the kind of next question or next example within the anti-randomization documentation kind of references question 5A from homework 7, where this question is now having to deal with randomizing the UART and all of its various parameters and functions. So in this question, having to randomize, which UART are you going to be using that's going to process this interrupt server routine, right? Are you going to be using UART 0, UART 1, UART 2, all the way up to UART 7? And then for that specific UART, then you need to be able to randomize, what's the communication mode of the UART? Is it gonna be receiving, transmitting, or receiving and transmitting? And then having an option that reflects that for enabling the interrupts. And then also randomizing the baud rate, um, and how that data is going to be sent, and then also randomizing all the different parameters of the frame format. So how many, randomizing how many data bits are going to be set, and if you're going to have FIFOs enabled or disabled, and your stop bits, and then your even or odd parity bit. And so getting into the code of how this is all randomized, pretty most of it's pretty simple and similar to the last question that we looked at, which was homework 1, question 5. And so yeah, similar to that, the different modes and the different baud rates or all the possible modes are written as strings, and they're stored within the string array. And then for the baud rates, we just have 5 possible baud rates that are stored within an array as well. And then, similar to that homework 1, question 5 question, we then just pick a random index or random string from this array, and then a random index or random number from this baud rate array. So here you're picking a random number between 1 or 1 through 2, and that's going to represent then the index that you're going to pick, or the string at that index that you're going to pick, and then set that as a parameter called UART mode. And then we do something similar for the baud rate. If I can find that, so right here. So here, instead of, I guess, picking a random integer to represent the index, you're just picking a random element at random using this random choice, and then setting that as a parameter called baud to then be able to reference that, show that within the question UI and question.html. And then something very similar is done for actually picking the UART module. So using a random number generator to, pick a number between 0 through 7, and then setting that as a parameter, and as a parameter called UART number. And then these all get reflected. So the UART mode, the baud rate, the UART number, those all then get referenced in question.html to then actually show the user, these different randomized parameters. And then kind of the more tricky randomization that we do for this problem is actually randomizing, the different characteristics in the frame format. So I guess you could, if you wanted to, you could do a similar approach to what we're doing now, where you define all of the different options within an array, and then you randomly pick an index to then pick a random element within that array, and do your randomization that way, similar to what's being done with picking the communication mode and the baud rate. But what the previous team has set up is a little different, and that's kind of what we continue to use for now. And so that's where these register config import files come from. So if I switch over to those, so kind of the main one here, main file here is this register config file, where in the Python code it actually references this rule set class, and it has the parameter UART. And by doing this, you can then capture all the data from this rules-UART.json file data, or you capture all that data. And so if we look at that JSON file, every I guess block within this JSON file has all the different configurations for all the different characteristics in the frame format. So for example, this first block here is for the parity bit. And the two options that you can have for the parity bit is for it to be enabled or disabled. And then for the next block here, it focuses on uh, the possible data bit configuration, where you can have four possible options for the data bit. If it can be 5 bits, 6 bits, 7 bits, or 8 bits. And then, same thing with like the third chunk where it's focusing on the FIFOs, where they can be enabled or disabled. And then, kind of repeating that process for your stop bits, your even parities, having an even parity or odd parity, having it enabled or disabled, and then a send break. So going back to the Python code, taking a better look at how that UART file is, really used. So here it's referencing or calling that rule set class, where it's using the UART enum. So it's our UART parameter. So then it's getting all of the data from that rules art slash or the all of that UART data that we saw earlier, storing that into this UART rules, and then it can use a function called generate to then create a random configuration of all of that JSON data. So then picking one option out of each of those collections within that JSON file and putting that into a variable called config, and then this get readable options function is called to kind of rearrange that that random configuration of data that was gotten from that JSON file into a more organized format that can easily be used to create a list within a list of that data in the question, and that's stored into a variable called options list. And then kind of this code right here is removing some of the options that that were made in the JSON file or that were put in the JSON file from the previous team but aren't necessarily needed for this team, so or that aren't necessarily needed as now for this question. So instead of modifying the JSON file, I'm just modifying the random configuration list that is returned from calling UART-rules.generate. But then in the question for actually displaying that randomized configuration within the question, all you need to do then is, or I guess I kind of skipped over this, but that options list is then set as a parameter called frame format, and then in the question.html file, you can then reference each individual option that was selected within that frame format. Since it will be in a list format, you can use this annotation here, so saying start at the beginning of the frame format list and then go until the end of the frame format list, where everything or every element within the list will be displayed as an unordered list. And then that's how you ultimately get, how you get a randomization of the frame format, or how we get a randomization of the frame format, and then display that all of those randomized parameters within the question itself. And then there will be another video that kind of explains the auto grading process for this type of question. And then one question you might have is, how do you go about randomizing the GPIO ports that are used within the question, or within the code of the question, since every individual UART will be using a different GPIO port, or is associated with a different GPIO port. And the way we do that is also within circuit.py. So I kind of made a customized PCTL table that's very similar to the table in the datasheet, and And so I have this function here called find the GPIO port for the specific UART, where the input is the picked UART number. And so what it'll essentially do is it'll go through this table. It's like for this question, it's using UART 2. So it'll go through this through every, I guess, individual array within this table, and it will find U2RX, U2TX, and if I go through here, it'll show up with GPIO port D. So then this function will return D, and then it will set D as a parameter called GPIO port. So then in the code that's displayed here, the actual port number is set by the GPIO port parameter, and updating the code to make sure it properly reflects the UART that's being used within the question that's being processed by an interrupt service routine. And yeah, that's how we go about randomizing a different question that is kind of a little more technically involved, with having to randomize the UART and then randomizing its different parameters, and then also randomizing the GPIO port that's used with the UART.